So we have here our example 9.2. Sabi dito, find an expression VC. Hanapin na natin yung expression of VC which is valid for t is greater than 0 on this circuit. So ito yung circuit natin, class. Okay? Meron kang voltage supply, inductor, capacitor, resistors. Okay? At t is greater than 0, the switch is closed. So ibig sabihin, class, itong dalawa na-isolate. So as if nung nag-starting time, as if ito na rin makikita natin. Kasi ito, sinolo na ng resistor yung ating voltage. So, wala ka na makukuhang voltage kasi andito na lahat. Right? So, as if parang ganito na tayo. Nagkaroon na tayo ng parallel RLC circuit. Okay? So, hanapin din natin yung value ng ating VC. So, class first, yung pinaka-first step is hanapin natin si alpha and si omega. Kasi, siya yung mag-identify kung anong case ba tayo? Overdamp, underdamp, or critically damp? Okay? Now, class, bakit importante na malaman yan? Kasi, ito yung sinasabi ko. Meron tayong table dito. This one, which is found din naman sa book nyo. Okay? Kasi, class, kapag overdamp, critically damp, or underdamp, ito yung ating criteria, di ba? Na-present ko na kanina. Nag-iiba yung ating response or formula. So, kapag ka-overdamp, ito pa yung example natin, ano? Ganito siya. Kapag ka-critically damp, ito naman. Underdamp, this one. Which we'll have example one by one. Okay? So, ayun. So, again, it's important to identify kung anong condition siya. And also, kung anong type siya. Series ba siya or parallel? Because class, yung omega natin, take note, same lang siya for series and parallel. But yung ating alpha, kapag ka-parallel, ito yung formula. Ito yung ginagamit pa muna natin. Diba? Kasi andito pa tayo sa parallel na example. 1/2RC. Class, kapag ka nag-series na sila, iba na yung formula niya. But although critically damp siya, pero series, same pa rin. Okay? Itong alpha nagbabago, depende kung series or parallel. Itong ating response nagbabago, depende sa kanyang condition. Okay? So, ayun. So, the first step is to identify yung ating alpha and omega for us to decide kung anong klaseng condition siya na belong. So, nasulat ko na dito sa gilid, our alpha is 1/2RC. Substituting the values, you have 125K. Yung omega, 1/LC. Given naman to sa circuit, diba? Kasi nga may value na yan, you have 100K. So, if you notice, our alpha is greater than omega. So, ibig sabihin, this is overdamp. Okay? Yung S1 natin, class, this is just negative, anong formula? Negative alpha plus minus. S1 is plus, S2 is minus. Plus square root of alpha square minus omega sub 0 square. You have negative 50K. For this one, negative lang to, pinalitan, negative 200K. Class, i-pause ang video, i-solve sa calculator. Okay? Alright, so assuming tama na yan, let's proceed. So, kapag ka-overdamp, ano nga sabi dun sa formula? Ang ating V of t is equal to A1 e to the S1t. Ito yung formula. Yung pinakahanapin natin, class, itong dalawa. Pag nahanap na itong dalawa, then we're good to go na. Okay, kasi nga, this is, di ba sa differential equation, meron tayong dalawang arbitrary constants, di ba ang tawag dito? And how do we solve for arbitrary constants? Di ba we need initial conditions? Alright, so yung first initial condition na pwede natin gamitin, class, is at t is 0, negative. Kasi, yung VC of 0 natin, class, mahahanap natin yun. And magagamit natin siya sa 0 positive because it doesn't change. So, V0 at 0, ito yun. Yung kanina. Kanina, class, nung hindi pa na-close yung switch, this one is open, diba? This one is short. So, yung voltage nitong capacitor is just the voltage nito. Diba? And, they are in series. In series, you can perform here voltage division. That would be 150 times 200 divide 300 plus 200. That's gonna give you 60. So, yung V0 natin, class, is 60 volts. Okay? So, substitute natin siya, class. Yung V0 natin is 60 is equal to A1 e to the S1 natin, class, is negative 50K. T This a2e to the s2 is negative 200k t. Class, we are considering at t is equal to 0. Kasi nga, di ba, nakuha natin yung voltage at t is equal to 0. So, e to the negative 50k times t, di ba, it becomes e to the negative 0. Eh, di ba, e to the negative 0 is 1. So, I could just replace this with 1. 1. Simplifying the equation, I now have a1 plus a2. This is my first equation. Class, isang equation pa lang, I cannot solve the 2 pa. Kailangan ko pa ng isang additional equation. Okay? Now, yung isang pwede natin gamitin, class, diba remember, diba meron tayong formula ng VT? Class, if i-derivative ko si VT with respect to time, times ko siya ng C. No, formula to, C dV dt. Diba that is IC? Yes. So, ibig sabihin, kung multiply ko lang ito ng capacitance, equate ko siya sa IC, then that could be my another equation na makakatulong para ma-solve si arbitrary constants. Okay? So, hanapin muna natin si IC. Ano ba si IC? Based on the equation, the figure. Tingnan niyo yung figure. May arrow tayo pababa. Di ba meron tayong IL plus IR plus IC is equal to 0 kasi pababa sila, class. Yung ating notation ng current dito is same lang kanina. Ha? Ayan. So, kung kukunin natin si IC, this is equal to negative IL minus IR. Negative IL. What would be your IL? Class, diba ito yung IL? Ito yung kanina. Okay? This is at T is 0 negative. Kanina. Ano ba si IL? Diba open? This is short. Itong current lang ito na dumadaan. You can just perform KVL. Yung current, class, across this resistor would be 150 divided by 500. That is 0.3. But class, itong current na caused by this voltage source is pa ganito. Diba? And our I here is baliktad. So this should be negative of the I na 0.3. So this is negative times negative 0.3 minus IR. IR, class, diba yung voltage nito, similar naman ng IR. Yung voltage nito kanina, diba that's 60. Divide mo lang ng 200, that is your IR. So this is 0.3 minus, this one is also 0.3. 0.3 minus 0.3, our IC is 0. Okay? Okay. Now, substitute natin siya dito, class. 0 is equal to, or IC is equal to C. Ano ba yung C natin? 20 nano times derivative ni V. Ito si V. Ito, ano ba yung derivative ni V? Ano nga ulit ang derivative? Sige, sulat natin. dt ni A1 e to the negative 50k t A2 e to the negative 200k t. Class, divide ko lang siya dito. Lipat ko sa kabila. 0 over number is 0, so 0 pa din. Okay? And I'm gonna take the derivative of this. This is going to be negative 50k A1 e to the negative 50k t minus 200k A2 e to the negative 200k t. And again, we are considering t is equal to 0, so magiging 1 ulit to. So we are left with negative 50k A1 minus 200k A2. This is equation 2. Plus, using two equations to ano, paggamitin ko na lang si calculator. I'm gonna press mode, 5 equation, and 1 on my first equation. This is 60. Sa other equation, this is negative 50k, negative 200k, and 0. That gives me A1, which is 80, A2 is negative 20. So class, since meron na to, going back dito, I can now write na yung VT pala is A1 na 80 e to the negative 50 kt minus 20 e to the negative 200 kt. This is your final answer. Ito yung magiging voltage ng ating parallel RLC. Okay? So that is example 9.2.